Hello dear viewers, I'm your friend Shadab Imam and currently we are dealing with the topic of queuing theory. In today's lecture we are going to see some more examples on model 1 which is MM1 infinity model. And in lecture number 89 we have discussed this model in detail and we have derived various formulas related to this model. So if you have not watched that video, please go and watch that video first, then come to this video. So let us move on with the problems. So before moving on with the problems, let us have a recap of the formulas we require to solve MM1 infinity model. So these are the 10 formulas we need to remember. So let us see one by one. So first formula is probability that exactly n number of customers in the system. So it is given by Pn and it is equal to lambda by mu to the power n multiplied by P0. Now let us see the next formula. It is given as the probability that no customer is in the system. So that means the probability of having zero customer in the system, it is given by 1 minus rho, or we can show as 1 minus lambda by mu. So let us move to the next formula. Probability that the server is busy, or it is also known as utilization factor, and it is represented by rho, and rho is equals to lambda by mu. Now let us move ahead. Probability that the number of customers in the system is greater than capital N. So in order to find this, we need to have lambda and mu, lambda by mu to the power capital N. Now let us move ahead. Average number of customers in the system. It is also known as length of system. So whenever it is talking about system, we will find out length of system. It is given by rho upon 1 minus rho. And if we put rho equals to lambda by mu, we can find this equation in terms of lambda and mu. Now let us move ahead. The next formula is the average number of customers in the queue. It is represented by LQ and it is given by LS, that is length of system, minus rho. Now if we need to find the formula in the form of lambda and mu, we simply will put rho is equals to lambda by mu, and in that manner we can convert our formula in the form of lambda and mu. Now let us move ahead. Average waiting time of customer in the system, and it is given by Ws and it is equal to Ls by lambda, where Ls is the length of system. Now again here, if we need to have this formula in terms of lambda and mu, we can convert it by putting rho equals to lambda by mu in the formula of Ls, that is the formula of length of system. Now let us move ahead. The next is average waiting time of customer in the queue. It is given by WQ and it is equal to LQ by lambda, where LQ is the length of queue. And the next formula is probability that the waiting time in the queue is greater than time t. So it is given by lambda by mu multiplied by e to the power minus of mu minus lambda multiplied by time t. And let us move ahead with the formula. Probability that the waiting time in the system is greater than time t, and it is given by e to the power minus of mu minus lambda multiplied by time t. So these are the 10 formulas we need to remember. Now let us move ahead. Here the problem says that goods truck arrive randomly at a stockyard with a mean of 8 trucks per hour. A crew can unload a truck in 6 minutes. Trucks waiting in queue to be unloaded are paid a waiting charge at a rate of rupees 60 per hour. Operatives are paid a wage rate of rupees 20 per hour. It is possible to augment the crew strength to 2 or 3 or 4 operatives per crew. When the unloading time will be 4 minutes or 3 minutes respectively per truck. Find the optimal crew size. Now let us see the solution here. In this problem, it has been given that the trucks arrive randomly and the arrival rate here is given as 8 trucks per hour. And the service time here is given as 6 minutes. Now, the service rate of a crew can be given by 60 minutes per hour by 6 minutes per truck, and this will come as 10 trucks per hour. So our service rate mu is 10 trucks per hour, and the waiting charge to the trucks is rupees 60 per hour. Operatives wage is rupees 20 per hour. Now it has been said that it is possible to augment the crew strength to 2 or 3. This means that this waiting time, that is 6 minutes, is for a single crew. So this is the service rate for a single crew. Now let us understand this problem as a whole, and we can see that trucks arrive at a certain rate which is given as lambda equal to 8 trucks per hour, and there is a crew to unload this truck. While this truck is unloading, the other trucks are waiting to be unloaded in the queue, and they were paid a waiting charge of rupees 60 per hour. Now it has been given that the crew consists of 4 operatives. Here it has been given 4 operatives per crew. So a crew has 4 operatives, and the operatives are paid a wage of rupees 20 per hour. Now what it has been asking is, there is a possibility to have 2 crews. Now when we have 2 crews, the service rate changes from 6 minutes to 4 minutes. Now as for this, our service rate changes. So this is our new service rate when we have 2 crew. So this is coming as 15 trucks per hour. Similarly, we can also have 3 crews. So when we have 3 crews, our service rate changes as 60 by 3, which is equal to 20 trucks per hour. So when there is a single crew operating, the service rate is 10 trucks per hour. When there are 2 crews, the service rate is 15 trucks per hour. And when there are 3 crews, the service rate is 20 trucks per hour. So let us move ahead with the problem, and let us say there are 3 conditions when we are having 1 crew, when we are having 2 crew, and we are having 3 crew. Now the total cost is equal to the cost of waiting of trucks plus the wages of operatives. So it is same for the second condition and for the third condition. Now let us first calculate the wages of operatives. Now when we have a single crew here, when our crew is 1 and each crew is having 4 operatives, so we have 4 number of operatives here, and each operative will be paid a wage of rupees 20 per hour. So by multiplying this, we will get the wage of operatives per hour. So this is 80 rupees per hour when there is a single crew. Now when there are 2 crew, the wage rate increases to rupees 160 per hour. So here there are 2 number of crews, and each crew will have 4 operatives, and they will be paid a cost of rupees 20 per hour. So the total cost or the wage of operatives is rupees 160 per hour. Similarly, when we have 3 crews, this will be 3, the number of crew will be 3, and there are 4 operatives, and each operative will be paid rupees 20 per hour. So the total wage of operatives is rupees 240 per hour. Now let us calculate the second part, that is the cost of waiting of trucks. In order to calculate this, first we need to calculate the waiting time of trucks per hour, because we have calculated the wage of operatives per hour. That's why we need to calculate the waiting time of trucks per hour. Now it can be given as WQ multiplied by number of trucks per hour. Now WQ is the waiting time of a truck in the queue. That means this is the waiting time of a single truck in a queue, and number of trucks per hour. So the number of trucks per hour can be given by lambda, which is the arrival rate per hour. So this is given as lambda, number of trucks per hour, and we know that WQ, that is the waiting time in the queue, is given by this formula, which is lambda by mu multiplied by mu minus lambda. Let us put the value of lambda as 8 and the value of mu as 10, because we have calculated that when the crew is 1, our service rate mu is equal to 10. So by putting the values here, we'll get 16 by 5 hours. That means the total waiting time of trucks per hour is 16 by 5. Similarly, we can calculate this when there are two crews. So the value of WQ is lambda by mu multiplied by mu minus lambda, and the number of trucks per hour is lambda. Here the arrival rate is same, lambda is same, which is equal to 8. The value of mu is changing. Previously, when there is a single crew, the value of mu is 10. Now here the value of mu will be 15, because as the crew size increases, the service rate also increases. So after putting the values of lambda and mu here, we will get this value as 64 by 105 hours. Similarly, we will calculate this for 3 crews. Here we will put the value of mu equal to 20. So after putting these values, we'll get this equal to 4 by 15 hours. So the cost of waiting time of trucks can be given as 16 by 5 multiplied by waiting time cost. So it is given as rupees 60 per hour. So this is 60 multiplied by 16 by 5, which is equal to rupees 192 per hour. So this is cost of waiting time of trucks. Similarly, this can be calculated when there are two crews. So the cost of waiting of trucks is 16 by 105, which is this, multiplied by 60. It is coming as rupees 36.60 per hour. Similarly, here also the cost of waiting time of trucks is equals to 4 by 15, which is this, multiplied by 60, and it is coming as rupees 16 per hour. Now let us find the total cost, which is equal to the cost of waiting time of trucks. So this is cost of waiting time of trucks plus wages of operatives. So we have already calculated these two terms, wages of operatives and cost of waiting time. So by adding these two, we'll get this as rupees 271 per hour. Similarly, when there are two crew, the wages of operative is rupees 160 per hour, and the cost of waiting time of trucks is rupees 36.60. So by adding these two, we'll get 196.60 per hour. Similarly, when we have three crews, the wages of operative is rupees 240 per hour, and the cost of waiting time of trucks is rupees 16 per hour, and by adding both we will get rupees 256 per hour. Now as we compare these three situations, we can analyze that when we are having two number of crews, we are having the minimum cost here, minimum total cost. So that's why we can say that the optimal crew size is 2. Now let us move on to the next problem, and here the problem says that on the average 96 patients per 24-hour day require the service of an emergency clinic. Also, on the average, the patient requires 10 minutes of active attention. Assume that the facility can handle only one emergency at a time. Suppose that it costs the clinic rupees 100 per patient treated to obtain an average service time of 10 minutes, and that each minute of decrease in this average time would cost the clinic rupees 10 per patient treated. How much would have to be budgeted by the clinic to decrease the average size of the queue from 1 by 3 patients to 1 by 2 patients? So let us solve this problem, and we have been given the arrival rate which is equal to 96 patients per day, or we can simply say that 96 by 24, which is equal to 4 patients per hour. Similarly, there is a service time of 10 minutes is given. So the service rate mu can be given as 60 minutes per hour by 10 minutes per patient, which is equal to 6 patients per hour. So the arrival rate lambda is 4 patients per hour and the service rate mu is 6 patients per hour. And the cost for treatment for 10 minutes is rupees 100 per patient, and the increase in cost per unit decrease in time is rupees 10 per patient. So this is the increase in cost whenever the time is decreased by 1 unit, that is by 1 minute. So it has been given how much would have to be budgeted by the clinic to decrease the average size of the queue, and this is called the queue length, average size of the queue, from 1 by 3 patients to 1 by 2 patients. So first of all, let us see that if this arrival rate and service rate is having this length of queue or not. So we know that the length of queue can be given by LQ, which is equal to lambda square by mu multiplied by mu minus lambda. Let us put the value of lambda equal to 4 and mu equal to 6. So we'll get 1 by 3 patients. That means for this arrival rate and service rate, we will have the length of queue as 1 by 3. Now, if we reduce this length of queue from 1 by 3 to 1 by 2 patients, keeping the arrival rate constant. Now we know that the arrival of patients is independent of clinic, what clinic choose to do. That means clinic have no choices of changing the arrival rate here. They can only alter the service rate, which is mu. So the arrival rate lambda will remain same, which is equal to 4 patients per hour, and we need to find out the service rate. So let mu1 be the new service rate for LQ1, that is the length of Q 1, which is equal to half patients. So let us change the value of LQ, which is 1 by 3, to LQ1, which is equal to 1 by 2 patients. And for this value of LQ1, we will find the corresponding value of mu1. So we know that LQ is equals to lambda square by mu multiplied by mu minus 1 lambda. Now this LQ has been replaced from 1 by 3 to 1 by 2, and the arrival rate does not change. So the value of lambda is as it is, only the service time changes. So the service rate is replaced as mu1. So let us put the value of LQ1 as 1 by 2 and lambda equal to 4 and find the corresponding value of mu1. So after solving this, we'll get some quadratic equation like this, and when we solve this quadratic equation, we'll get the value of mu1 as 8 and minus 4. Now we know that the service rate cannot be negative, so that's why we will ignore this value of minus 4, and finally the value of mu1 will be 8 patients per hour. So we can see that the service rate here will be 8 patients per hour for the length of queue to be 1 by 2 patients. Now let us from this service rate find the time required for service. So the average time required by patient is equal to 60 minutes per hour by 8 patients per hour. So this will be given as 15 by 2 minutes per patient. So it is equal to 7.5 minutes per patient. Now our service time is reduced from 10 minutes to 7.5 minutes per patient. So let us calculate the decrease in service time. So this is 10 minus 7.5, which is equal to 2.5 minutes per patient. And now let us calculate the new budget for the clinic, which is equal to the previous budget plus the decrease in service time in minutes multiplied by rupees 10, because we know that the decrease in service time for each minute will increase the cost by rupees 10. So our previous budget is rupees 100, and we know that decrease in service time is 2.5 minutes per patient. So this is 2.5 minutes per patient, and each will cost rupees 10. So after solving this, we'll get a solution as rupees 125 per patient. So as per the new budget, the clinic has to spend rupees 125 per patient. So I hope you understand this lecture and this is useful to you. Please like, subscribe and share. Have a nice day. Thank you.